computers, so I hope I don't have my dad talking in the background.
Okay, that's fine. Actually, these problems where they simplify and give you a multiple choice, if ever there was multiple choice that hurt you instead of helped you, it's here.
Right.
Multiple choice do you no good whatsoever, and in fact, they actually make the problem harder if you try to prove. In other words, if I go here and try to prove whether that's equal to that, and then that's equal to that, and then that's equal to that, and so forth and so on, it makes the problem much harder. So let's ignore the multiple choice and see what we get. Now, unless there's something very unusual about the problem, for instance, if you had a tan squared, or a cotan squared, or a cosecant squared, then you might consider using the Pythagorean identities. But we don't see anything like that here. So the best strategy to take is just to change everything to sines and cosines. What's the numerator become?
Wouldn't it just become 1 over sine? Or, yeah, 1 over sine.
What's the denominator become?
It'd be sine over cosine plus cosine over sine.
And now you just have to apply algebra. Okay, what are we going to do at the bottom?
Find a common denominator.
What is that common denominator going to be?
It would be cosine sine, or sine cosine.
Either one. What's the numerator of the denominator?
It would be sine squared plus cosine squared.
What can I do with that expression?
That's just equal to 1.
Okay, so what I have is 1 over sine in the numerator, and in the denominator I have 1 over sine cosine. How do we simplify that?
Multiply by the reciprocal.
What do you get?
Wouldn't you just get cosine?
Yes. Now, I got this problem about 2 minutes ago, and I did it, and I looked, and I had this part blocked off like that. And I said, well, I'm sure I did that correctly. How come there's no cosine there? And then I realized that it's answer D, cosine x. All right, that's pretty much what we're going to do. Now, let me take it back that it's not useful to look at the answers. On this one, well, it's not particularly useful. Let's plow ahead on this one without looking at the answers again. Hold on. In other words, I was going to say, if all the answers are in terms of cotangent, secant, tangent, and stuff like that, well, then maybe I don't want to just convert everything to sines and cosines. Because clearly I don't have any answers that are sines and cosines unless after converting it I end up with cosine over sine, which would be cotangent. And then I saw answer D does have a sine in it. So let's play around with it. What can we do with this? In other words, one option would be to convert everything to sines and cosines and see what we get. There is another option.
Isn't it multiplied by the conjugate?
Yeah, and the reason that's an option is whenever you see that, or cosine minus 1 or sine minus 1, whenever you see a trig function added or subtracted to 1, well, we can't immediately apply any trig identity to it. But we know that if we multiply this thing by the conjugate, we're going to end up, that's difference of squares in the bottom, So the top, and I'm going to leave the top factored. I'm not going to combine those. You'll see why. What's the bottom become?
Isn't it 1 minus secant squared?
And what trig identity is that? If tangent squared plus 1 equals secant squared, then what is 1 minus secant squared?
Negative tangent squared.
All right. So I'm going to replace that with negative tangent squared, and that helps a lot because we got a tangent in the numerator. Okay. So now I can get rid of that tangent, get rid of that exponent, and we end up, and I can take this minus sign and put it in the numerator instead of the denominator, and that makes the numerator become secant minus 1 all over tangent. That's the answer we should look for. Well, let's see. What is this answer? That is 1 plus secant all over negative tangent. Still isn't the exact answer that I got.
We have the answers for all of these?
Well, don't give it to me yet.
No, I know, but should I go grab that?
Sure. Yeah, if you don't have it in front of you, go ahead and get it so we'll be able to check.
All right.
Okay, I see what I did, Mitch. I just made a math error. Go back to the top of this page. Notice that I'm supposed to multiply tan by 1 plus secant. Well, I multiplied tan by 1 minus secant. So let's change that to a plus. The bottom still comes out to be minus tangent squared. And now I can change that, lose that, and I should have this as an answer. 1, and I think that that is not that answer, but it is A. Notice what A is. In other words, this is our answer, the top. And I can put that minus sign wherever I like. I'm going to put it down there. And notice that negative cotangent is the same as 1 over negative tangent. So A is the correct answer. But these are tough because if you make one arithmetic error, it kills you. You are not going to come up with the right answer. And I dropped a sign. I turned a positive sign into a negative when I shouldn't have. All right, let's go make sure we do 3. It's significantly different. Here's the major difference with 3. Everything that involves verifying trig functions or simplifying trig functions doesn't have much of a real-world application. Its only purpose is to get you to memorize your trig identities. Truly, that's it. If you know your trig identities perfectly, then you're going to do real well on that. Starting with number 3, where it actually gives us a trig equation and wants us to solve it, there are plenty of real-world problems for this. I mean, all kinds of real-world problems have trig equations that have to be solved. Okay, and they want us to solve this on the interval from 0 to 2 pi, which means we're going to come up with all solutions that are in the unit circle.
Right.
The way to do these trig functions is to treat them kind of like algebraic expressions. If I told you that 2x cubed plus x squared was equal to 0, whatever method you're going to use to solve that, use it to solve our trig function.
All right.
It's the first thing we're going to do.
Couldn't you factor out a sine squared, sine x squared?
What's left?
2 sine plus 1.
Now what?
No, but set both of those equal to 0, and then.
So if I set sine squared equals to 0, that occurs, that means sine x is equal to 0. And where does that occur? Where is sine equal to 0 in the unit circle?
Isn't it just 0 and 180? Or
Yeah,
0 and pi.
and pi. They gave us the domain in pi, so they probably want the answer back in radians. And then the second part is what? That's only one solution.
And then it would be.
That we said equal to 0, so x equals minus 1/2 sine x, excuse me.
Yeah.
And where is sine x equal to minus 1/2?
Pi over 6. And.
Pi over 6, it would be equal to plus 1/2. So you got the right angle. The pi over 6, 30 degrees is the correct angle. But now find the two quadrants where it's negative.
It would be 3 and 4.
Okay. What's the equivalent of pi over 6 in the third?
So it would be 7 pi over 6, and then 11 pi over 6.
There you go. So there's your 4 answers. Those 2 and those 2. Now, in point of fact, usually you're going to have 6 answers when you have a cubic. The only reason we had only 4 was because when sine squared is equal to 0, that only produced 1 answer. Normally, that's going to produce 4 answers. If I said sine squared is equal to 1/2, then that's all 4 quadrants. So that would be pi over 6, 4 pi over 6, 7 pi over 6, and 11 pi over 6. But the fact that it's equal to 0 limits it considerably. It cuts it in half. So you only have 2 answers there instead of 4.
Yeah.
Let's see. I'm assuming that C was correct here.
Yeah.
Okay. Again, simplifying, which means coming up with a trig identity. Let's have a peek at the answers. We don't see any signs of cosines. There's a 1 over cosine, but that's also a secant. So if I turn that 1 over cosine into a secant, then all of my answers have nothing but secants, tangents, and all of that stuff. Which means I'm not sure that I want to convert everything into sines and cosines. Let's see. Cotangent. Yeah, I am sure. Let's do it. And the reason is I don't see any other way to proceed. In other words, I can call that 1 over tangent. But then that doesn't relate to tangent at all. That thing is only 1 over sine. So I can convert that to sine, that to cosine and sine, that to cosine and sine. And then when we're done, we should be able to turn it back into one of the multiple choices. So again, I prefer not to look really at the answers because it does nothing but hurt me until I come up with something. Well, that's useful. The top stays that. What's the bottom become? 1 plus cosine over sine. Flip and multiply. And we have sine squared over cosine times 1 plus cosine. Not particularly helpful.
Yeah, it is.
Why? What can we do?
Actually, can't you multiply that out so it's cosine plus cosine squared?
Yeah.
And then make that tangent.
No. A over B plus C, remember, does not separate. That is not equal to A over B plus A over C. It's if you have A plus B over C, you can separate it.
Oh, okay.
Let's rethink our strategy. Let's go back, and instead of doing what we decided to do,
wait, or could you change that sine to 1 minus cosine squared?
Multiply top and bottom by that, and that is going to be useful. Let's try that. That might be the way to go. Let's multiply top and bottom by the conjunction, or the conjunctive.
No, I was saying change the top and bottom to 1 minus, or the top to 1 minus cosine squared.
Yeah, I can do that. That is helpful. Change that to 1 minus cosine squared, which is the difference of perfect squares, which factors into what?
Isn't it 1 plus?
1, always do the minus first. And then there's a reason for that. It's because when you're memorizing difference of cubes or sum of cubes, there's a key way to memorize it. And the way to memorize it is the minus is always first, or the same sign as this one is always first. Okay, now the bottom, I got something I can cancel. Cancel that with that. So now I have 1 minus cosine over cosine. That I can split into two fractions. 1 over cosine minus 1. And that was answer D, I think. 1 minus 1 over cosine. Not quite. We got it the reverse. Why do I have it as the reverse? One minus cosine over cosine. Are any of those other answers even close to that?
Yeah. Isn't the A?
You're right. That's 1 minus secant. And that's secant minus 1. In other words, had I got fooled by the multiple choice. Do you see how?
Yeah.
Yeah, because I was looking at answer D, trying to make it look like D, instead of doing what I should have done, which was turn that into secant. You always do that. So secant of x minus 1, and I would have found the answer instantly. So I honestly think that if a teacher is trying to torture you, they are going to give you multiple choice trig verifications. Because it's pure torture. You don't learn how to do it. You never learn how to take a trig expression and prove that it's not something. Every exercise you've had is proving that it is equal to something else, not equal. And so proving that it's not equal to something else is actually quite difficult to do. How do you do it? It's not an easy thing to do. Think about it for a while, and it's very, very tough. All right. Simplify.
Yeah, these ones really confuse me. I don't like these.
Well, let's do the most obvious thing.
Multiply by the conjugate?
No. Add the two fractions. How do you add the two fractions? You come up with a least common denominator. What is the least common denominator going to be? The product of both things.
Yeah.
Right? Always. When you're dealing with variables, it's a common denominator. I'm not sure that it's necessarily the least common denominator, but it doesn't matter. As long as you have a common denominator, and usually when there's variables or trig functions involved, that's what you have to live with. Well, that's difference of squares factored, so what is that equal to?
When equal to secant squared minus 1.
Correct. Okay, and what goes up here in the numerator?
Secant plus 1, or...
Just remember that whatever you write has to equal this expression.
Okay.
You see why I had to write secant x minus 1? Because that's going to cancel, and I'm going to be left with that. Same thing over here. It would have been easier if I hadn't have written it like that, so I'll go back and write it correctly. And then I'll put it together. Because once you put it together, you can turn it into something else. And this has got to be secant x plus 1. Okay, so now if we combine everything, how many secant x's do we have in the numerator?
2.
The minus 1 and the plus 1 go away. And the bottom is secant squared minus 1. What is that equal to?
Is that cotangent?
No, tangent squared plus 1 equals secant squared.
Yeah, that's right.
Secant squared minus 1 equals tangent squared. And that's what we should see as an answer.
That's not even close to any of the answers.
No.
Oh, it's close to B.
Well, it would be a cotangent squared in the numerator. Do we have anything that looks like that? No, hold on. That's the problem with these, is you never know at what point you got to get it into their format. Let's see. If I convert this to sines and cosines, I've got 2 over cosine, all divided by sine squared over cosine. squared. And now if I flip and multiply, I have a 2 cosine in the numerator, and I have a sine squared in the denominator.
Close, but no.
Very close to D. Did I get my 2 in the wrong spot? Maybe. No, the 2 was always in the numerator. We came up with 2 secant x's. What else does this look like? In other words, what else is that? That could be 2 cotangent over sine. Is that an answer?
No. Kind of.
There's the cot. Yes, it is an answer right there, B. In other words, if you kind of take the philosophy of turning everything into numerators, which is not a bad philosophy to take, then this sine is going to become a cosecant.
Oh, yeah. Okay.
There's my answer. But again, it's guessing as to, you see how hard it made, you see how much easier this problem would have been if it had been a typical trig verification problem? In other words, if they'd have given us the left, if they'd have said, prove that that is equal to this, it would have been a piece of cake. But when they give us a multiple choice, we're not sure what we're supposed to prove that that's equal to. So all you can do is simplify it down as much as you can and then check your answers and see if anything even looks close. And it's not often very easy to tell if something does look close. All right, that's all of them. Hopefully that's been helpful. It's not an exact science when you're doing these simplifications into multiple choices. That's for sure. I mean, it kind of is. It kind of is. It's like this one. When you see a 1 minus secant, know that you're probably going to need to multiply by the conjugate. This one is always a factoring, and sometimes that's a quadratic. Have you seen the ones where they give you a quadratic in sine?
Yeah.
And then you just have to factor it like you would in algebraic quadratic and solve it the same way.
Yeah.
And this one, it's not real clear. What the heck did I end up doing here? I ended up changing everything into sines and cosines. And then figuring out that the answer was A. And here, it's pretty clear that you need to add these two. And the reason I say it's pretty clear is because to find the common denominator, you're going to multiply this by this. Well, that's difference of squares factored, so we know that that is secant squared minus 1, and that's equal to tangent squared. So I can take these 4 terms here and turn it into tangent squared almost instantly. And whenever you can do that, that's usually the way you want to go. When you can reduce the number of terms, when you can turn 2 terms into 1 or 4 terms into 1, that's what you want to do.
So if, like on a test, should I just cover the answers and just try to get to a point?
I'm tempted to tell you, yes, do that. I did these the best way I could possibly do them. And I only had 2 minutes warning. I mean, you sent me this 2 minutes before our session. And I did it off the cuff, and you saw how I did it. So I'm not convinced that looking at the answers helps. It could hurt even. What I would do is simplify it and then look at the answers, just like I did. I simplified it and then tried to find an answer that matched my simplification. Okay?
Yep.
All right, Mitch. Have a good week. I will talk to you next week.
All right.
Bye-bye.